Hi, everybody. Professor Monty talking about the mean of a data set. Now, the mean is just the mathematical average of a data set. So when you see mean, think average. And it's the same average we've always done before, where we just add up all the values and we divide by however many values we have. So if the mean, we're going to use the symbol X bar. That's for specifically the sample mean. If we have the whole population, it's a different letters, mu. But X bar, sigma X, that means we add up all the X values and we divide by n the number of data values. Okay, so here's an example. Kids in my family. There's 6 kids in my family. My oldest brother has 4 kids in his family. The next oldest brother has 4 kids in his. Down to me, I have 3 kids in my family. But if we want to find the average number of kids in all of our families, we would find the mean, the average. And so I add up all the X values. I say 4 plus 4 plus 6 plus 2 plus 1 plus 3. Divided by the number of data values. Well, there's 1, 2, 3, 4, 5, 6 of them. So n equals 6. So then my X bar, I add these up. I get 10, 14, 16, 17, 20. Divided by 6. The general rounding rule in statistics is you go to 1 decimal place in your calculations more than the data values. Since the data values are whole numbers, I'll go to 1 decimal place. So when I do this, I get about 3.3 when I round it off. And that's average number of kids per family. Okay, that's the mean. Now, if I have a frequency distribution, I can do this. There's just a slight change to it. So let's say I have the same data here. We'll keep all that down there. But now say it says kids in family and frequency. And then let's see, there's 1s and 2s and 3s and 4s and 6s. One of the siblings has 1 kid. One has 2 kids. One has 3 kids. That one would be me. 2 of them have 4 and 1 of them has 6. So the total, if I add these up, 1, 2, 3, 5, 6, n equals 6. And what I do for the mean, I could just add them up. I could add 1 of these, 1 of these, 1 of these, 2 of these, 1 of those. But say there's a lot of numbers there and the frequencies all vary. What it is, it's the number. Let's say it this way. It's the sum of the number times the frequency. And then divide by n again, the total number that we have. So in this case, what I do is I say, oh, the number there was 1, but I'm going to multiply that by the frequency. There was 1 of them. Plus 2 kids, there was 1 of those. Plus 3 kids, there was 1 of those. Plus 4 kids, there were 2 of those. Plus 6 kids, there was 1 of those. And then I'm going to divide it by n, which is 6. We'll squeeze that in right here. So if I do this, this is a 1 plus 2 plus 3 plus 8 plus 6. All divided by 6. And then when I add these 10, 19, 20, I get 20 divided by 6, which again is 3.3. I get the same 20 divided by 6 as I did here. I get the same 3.3, obviously, when I divide. But that's the idea. It's the number times the frequency will give you the total if you have a frequency distribution, as opposed to the numbers just written out individually. But anyway, that's the idea. So the average is another word for the mean. So when you say mean, think average, add up all the values, divide by the number of values, and you'll get it.